So today we're going to be looking at the fraud detection service as our example application. I'll walk you through several scenarios that show how Checkmarx One Developer Assist works directly inside the developer's workflow, identifying vulnerabilities the moment they're introduced and guiding remediation with context-aware fixes. The Developer Assist agent covers a wide range of issues: hard-coded secrets, insecure container images, misconfigured infrastructure as code, unsafe coding patterns, and vulnerable or even malicious open source components. Importantly, the agent also includes the ability to safely refactor code so remediations don't break compatibility with existing functionality or other components. So I will open up my Checkmarx One results. I've already selected this high severity deserialization issue. So we'll open up the Checkmarx One tab here and note, hey, we have information about this vulnerability, fraud detection, line 127 all the way through 132, and we're going to go straight to the sink here. So when we load this up, we'll see it starts to mark everything up in the IDE. We get the squiggly line, this markup underneath our code, as well as a badge here showing, hey, indicating high severity. So here's a high severity coding flaw. Now, in this case, we would actually like to remediate this using Developer Assist. So I can go back again, I can hover, and I can say fix with CX1 Assist. And this is going to start the remediation process. So the first thing that happens is we provide the model here with a detailed set of instructions, right? And we'll see what those instructions entail. But in short, the first thing that happens is we reach out to using the code remediation tool to a Checkmarx MCP server that provides detailed information on this particular type of vulnerability and remediation instructions. And you'll see that the remediation instructions have already been implemented by the agent. And now we're going to go through a verification process, right? So we'll verify that we can actually compile the application still, that it runs properly. We go through the syntax and build checks and confirming that all of these tests pass, right? So the vulnerability is eliminated and the app continues to function normally. And then finally, we're provided with a summary of everything that happened, right? So the files that were changed and a summary of what was changed, the security improvements that were made, and then the status, right? Everything passed, everything was remediated here. So this is a simple, but also a great example of autonomous remediation. The agent follows strict remediation steps, changes only what's necessary, and validates the results. We're going to open a Docker file here, and we'll go through and modify it briefly so that we initiate the scan. And we see, once again, we get that markup throughout the Docker file. We have a low, a few mediums, and at the very top, a high severity vulnerability. So in this case, the Docker file is using a vulnerable base image, Python 3.13.4 Alpine as the base image, and Developer Assist detects the issue, and we're able to trigger the fix. So in this case, once again, the agent activates. It reaches out to the Checkmarx MCP server, in this case using an image remediation tool. The agent will go through and select the safest upgrade option. And then it will go through and make the change. And you'll note here, the change has been made to the Docker file. Now we have 3.13.6. And then, once again, we're going to go through the heavy lifting for the developer, right? We're going to go through the process of validating the fix, the change. So the Docker image actually builds successfully. That the container will actually start and run on port 5000. We're going to actually verify that everything's running properly, that all CVEs have been eliminated, and that there are no breaking changes here to the environment, to the ports, to the file system, etc. So the developer doesn't have to trial and error this. Checkmarx Dev Assist tests and confirms that the app works properly before wrapping things up and presenting the results. So in this case, this isn't just about swapping a base image, right? Developer Assist ensures that the entire stack remains functional. It fixes the Docker file, it resolves any downstream dependency issues, it updates the code where needed, and validates that everything with a clean build and runtime test. And that's potentially hours of manual effort eliminated and confidence that the application remains both secure and operational. So let's open requirements.txt, our manifest for this Python project. So here you'll note we get a lot of markup, some highs, some mediums. We're actually going to work on Flask. So let's look at Flask, the high-risk package, right? Flask version 1.1.4. We're going to go through again. We could view details. In this case, we're going to shortcut and just implement the fix. So fix with CX1 assist. So in this case, because it's been flagged as high severity, we're going to go through and be given a recommendation for remediation using the package remediation tool. We'll provide remediation steps. In this case, we're going to upgrade to Flask version 2.2.5. We'll install it. We'll do some testing. And importantly here, you'll see safe refactoring kick in. So we're not only going to upgrade the package, we're actually also going to go through and make related changes, right? In this case, potentially code level updates to address any breaking changes due to this upgraded or these upgraded packages. And you can see that happening right now. I need to check for breaking changes, right? We see some deprecated APIs or deprecated functions or methods here. And we're going through and fixing or updating the fraud detection code itself. So we go through the validation process. We go through unit tests. So in this case, we're going to create a custom test because the test didn't actually exist. And look, we've identified some additional changes that need to be made. Now keep in mind, while this is a longer, more complex process than some of the other remediations, the automation provided through the combination of the Checkmarx Developer Assist agent and the enrichment from the Checkmarx MCP service, as well as, in this case, Claude, we're going through and we're making substantial changes, substantial refactoring to the code to ensure that we're able to support the upgrades, the updates to these packages. And you can see here there have been substantial changes, right? Not just import statements, but other packages being upgraded for compatibility's sake, changes to the actual calls that are being made, etc. And so this process, not only doing the research, implementing the changes, but then going through the laborious testing process would take a developer a substantial amount of time, certainly more than the 5 minutes or so that it took us using the Checkmarx Developer Assist agent. With Assist, the fixes are guided, they're validated in real time inside the IDE. So developers save time, organizations reduce risk, and security becomes part of the natural coding process, not a blocker. That's the key. Secure code in flow, safe refactors that prevent breakage in immediate pre-commit feedback, so issues are fixed right the first time.